Okay, so hello everyone. You are welcome to today's lesson. And in today's lesson, we are going to continue from where we left off in our previous lesson. In our previous lesson, you know that you were given this as the assignment. Okay, after walking you through all the questions related to, exactly, the question of the form of the question that we have before us. So in effect, the question before us should be trivial. Okay, however, please take note. I'm going to walk you through, the solution. And again, I will draw your attention to salient points in terms of your presentation. After that, if you still have any outstanding issues, please don't hesitate to let me know. All right, so in a context, I'm reading the question. Papa, Osei, and Anani are asked to solve a problem. The respective probabilities that they solve the problems are, okay, so that is what you have there. Okay, I think this should have been probabilities. Okay, but it's okay. Calculate the probability that, so we are finding the probability that all of them solve the problem. None of them solve the problem. None, one of them solve the problem. V, exactly two of them solve the problem. Then V, at least one of them solve the problem. Okay, so quickly, let's go and look at what's the solution. Okay, all right. So please take note. Remember, I've told you in probability, anytime, the probability comes with, the question comes with, probability question comes with an information where the information you can see quantities, or items with their respective quantities or numbers. Then there is a way to go in terms of how you start. You get your representation. After your representation, then you extract the data in terms of numbers. However, if you read this question carefully, you can see that we are not giving the numbers. Okay, but we've been given probabilities of events, 3 of them for that matter. Okay, so in this case, when you are setting out your representation, which, you have to anyway, but you have to be careful. In this situation, your representation will not be a set because you don't know the number, you only know the probabilities. So please get the distinction right. So in that regard, this is how we are going to proceed in terms of our presentation. So you will then you can see if I read this, I have Papa, Osei, and Anani, were asked to solve, a problem. And their respective probability that they solve. So it means that we've been given this probability that we have here is the probability for the event that the first one, the event, Papa solve what's the problem. The second one is for the event, Osei solve the problem. Then the third one, your event, Anani solve the problem. So in this case, it is your event that you are going to represent by letters, so that going forward you write less. Okay, so here I'm going to use A to be equal to, and here, like I said, your A, the letters that you have there are representing your events. Take note, your event, which you don't know the number. So in that case, when you are getting your definition, you don't put it in curly brackets. It is only set that you can get the numbers. But if it is not a set, then it means you can't get the number. Directly from the question. So in this case, we are going to let A, be, I'll start with P because that's this. I will move in that same order. Forgive me. However, if this happens to you, the order doesn't really matter. You can still use A for Anani, then P for, the third one, which is the O. I will give you a vital information there, which is in the first video. But because most of you, if not all of you, are saying you didn't watch the video, that's why I will go back a little, or I will, chip in that as well. So with this is what we have. So I will let P, be equal to the event that what Papa solved the problem. So I'll write Papa, solves, solved the problem or solved the problem. That's my first event. Take notes. Papa solved the problem. Please don't write Papa. Other than that, if you are going to extract the data in terms of probability, here you extract the data in terms of probability, not in terms of the numbers, because we're not giving the numbers, we are giving the probability. Otherwise, if you represent this one by Papa, then it will be probability of Papa, which doesn't make sense. Okay, so make sure your event makes what sense. Okay, so then you go to the second one. Okay, ordinarily, we could have used, okay, or we will use O to represent or say. However, in maths, and I think I've said this before, anytime you are getting a representation, avoid using O because you can confuse that with what? 0. So you must always avoid, if possible, and here is possible, we can avoid. Okay, so I will use S, the next letter, okay, S, to represent what? Okay, the event that Osei solves the problem. Hello, are you following? Hello, are you following?
Yes.
Okay, so in that case, okay, what will be, okay, so let me write, and our next one will be Anani, and that A has not been used, so I can use A is equal to, and that will be Anani, okay, solves the problem. Okay, so now this is what we have. Okay, so we've done our representation, so we can get the data here in terms of our representation, which will save us time. So I'm going to write, but from the question you've been given, okay, something will happen here. And again, I will advise you P of P. Okay, and you can see that again, there is that conflict. I hope you are with me. We've encountered this before, and I advise you. So here, this question is just to let you know that, okay, though you are at liberty, especially in your representation, to use, okay, any letter, but some of the letters, okay, will bring some sort of ambiguity, okay, or will bring issues going forward. So in that case, okay, this is what we are going to do. We have to change the P because we are going to use P to represent probability. Is my point well made? So it's not only in probability question. Okay, in math, generally we tell you to avoid using O to represent. Okay, but not the letter P. However, here, because we are doing probability, okay, we should also equally avoid using the letter P because we will use the letter P to represent probability of an event because of the notation of probability. Am I clear enough?
Yes, please.
Okay, very good. Okay, so on that note, okay, what letter do you think we should use? If you go to A has been used. You cannot use A. So it's PA. So any other letter of your choice apart from A and S that has been used. So which letter will you go for? Oops. Okay, which letter will you go for? Hello. Any letter, you just give me any letter of your choice apart from the two that I just mentioned. You are just getting a representation for your event. That's all, which you can use any letter. Only that usually we use the first letters for convenience sake. Okay, more or less for easy identification. However, where in the situation the letters cannot, okay, be used, or you know that, okay, to cause future problems, okay, you avoid. And that's exactly my point. So what letter do you want us to use?
D.
Come again.
D.
Did you say D or B?
D.
D. Okay, all right. So you said D, so we are going to use D. Okay, so this will be P of D. That is P, Papa solved the problem. And we are told, look at the response, the respective probabilities. So the first one is for Papa. So that will be equal to, okay, and you know how to read this. Once you define your D, so that's the more reason why you don't define your D as Papa. If you define your D as Papa, then it will be probability of Papa, which doesn't make sense. I've said that initially. Or if you define your D as the probability, okay, that Papa solved the problem. If you come here, you are going to write probability that probability or probability of probability that, and which will be tautology. So the same advice that you were giving when you were dealing with sets. Whenever you are getting your representation for sets, you never have number in your set representation. The number will come in when you are bringing or introducing the data. So take note. Probability shouldn't come in your definition. Probability will come in when you are introducing or bringing in your data. So in this case, what do we have? That we are told is 1/6. Okay, the second probability is the probability of what? Your S, capital S, and that is what? 1/8. I hope you are following. Okay, and okay, your last probability will be P of A. That's the probability that Anani solves the problem, and that we are told is what? 1/3. Is my point well made? Okay, however, before you start doing all this, okay, you would have read through all the questions. So you can see, okay, questions dealing with the complement. Because here we have all of them solve the problem. None of them solve the problem. So it means, okay, we have negatives in the question. So in that case, this is what we are going to do. From the question, we know we need the complement. That is the negative of what? Of, so that is not solving, okay, D not solving, okay, Papa not solving, which is what we have here. Then Ose not solving, okay, then Anani not solving. That will be the complement. Remember, not will bring us. So it means now I can write this implies. Remember the relation. You were told that, okay, probability of any event. If I know the probability of an event, okay, I know this will give me the relation, the complement of the event. Or I can have P, the complement of the event is equal to 1 minus probability of the event itself. So that's what we are going to use here. We know the probability of the event itself. We don't know that of what? Of the complement. So we can find that. So it means P, D complement, okay, will be equal to, we know it will be 1 minus this. I hope you are following. Okay, so because you've not watched the other video, other than I would have extracted the data straight away without explanation, because I know you will be with me. So you've made the work a little bit difficult this morning. Okay, so now it is going to give you 1 minus 1/6, which will give us 5/6. Okay, comma. Then PS complement. Okay, not solving will give her, that is Ose not solving will be 1 minus, okay, probability that Ose solves, which will give us what? 7/8. Is my point well made? And the last one, and P Anani, okay, not solving, okay, or couldn't solve the problem, will give us 1 minus 1/3, which will give us 2/3. Is my point well made? So here it's all about the data. If you get your data extracted, okay, correctly, the rest of the work will just be some basic analysis that you need to do to get all the possibilities at hand. Then you are good to go. Okay, so now we are going to the questions, okay, themselves. So in this case, what do we have? We are looking at probability that all solve, okay, the problem, or all of them solve the problem. So I'm going to write, okay, therefore P, and I know my event here, all of them solve the problem, but I will take the of them out and write all solved the problem. Okay, so take notes. All right, so now this is what you have. Okay, so you've stated your probability of, the event that you are supposed to find. So your contribution is now coming in equal to, okay, so if all solve the problem, okay, there is going to be only one possibility. Okay, and the possibility is that, okay, Papa solved the problem, Okay, and what? Ose solve the problem and Anani solve the problem. All of them solving the problem will be only this situation. Do you agree with me? So it means I'm going to get this P. Papa solve the problem is D. And okay, and let me use intersection instead. In the video, you were advised going forward you can use intersection. So you go and watch the video and you appreciate why. The normal circumstance, remember I've told you, intersection and end can be used interchangeably in probability. So it will be D, which is Anani solving, so Papa solving the problem. The second one will be Ose solving the problem, but Ose we represented that by what? S. Okay, and who else solving the problem? Anani, and Anani is represented by what? A. That is Anani solve the problem. So this will be the situation. And remember, in this case and in the previous video, we said that the events here, are independent. Anytime you see intersection or end, you know the rules that should come to mind. Multiplication rule. So we have two. Are the events dependent or independent? Obviously, you know that they are what? Independent. Because the fact that I am able to solve the problem or Papa is able to solve the problem doesn't give you any inkling, about the information that Ose will solve the problem or not. It's my point well made. So do you agree with me that these three events are independent events? Is that clear? So once they are independent, anytime you see intersection or end, they will multiply. So this will give you the probability of D. As you mature, you can choose not to write this times. So probability of S times what? Probability of what? A. Because you've not watched the previous video, that's why I am bringing in this. As you mature, this step will be out. So you move on to this from here to what we are going to write. You know P of D, that is 1/6. Times, you know P of S, and P of S is 1/8. So here is just substitution. Times, you know P of A, that is 1/3. So at this point, it's just calculator work. So you use your calculator to find the value. I'm waiting for you. Hello, are you there?
100
No, 1/144.
144.
144. Very good. So this is what you are supposed to get. Please, I hope you are following. I'm trying as much as possible. Not to bring in concept that you should have known from the. But still, I will have to explain to the best of your understanding. If you had watched the video, we would have gone beyond this by now. So straight away, maybe by now we will be done with the solution. But because we've not watched the video, that's why I have to bring in certain concept that you needed to have in the previous video. So this becomes the solutions to I. So let's go and look at that of what? The II. So II is not difficult. So go and watch the video. If your understanding is not perfect, you will get it. II, therefore, we are looking at P. None of them solve the problem. So I can just write none, solve the problem. And please, let me go back a little and say something there, again with your representation. With your representation, just as you cannot write Papa, you can't also write Papa solves. Please make sure you attach this, you add this. Papa solves, the problem. Other than that, if you come and write P, Papa solve, it doesn't make sense. It doesn't make your event precise. Please take notes. So make sure you define your event very well. So none of them solve the problem, which will be that of the II, will be P. We said Papa is not able to solve the problem. So this one, you have only one possibility. Papa is not able to solve, Ose is not able to solve. Then what? Anani, equally is not able to solve. So Ose not able to solve will be the complement. So let's start with Papa. Will be the complement. Papa is D, so it will be P, D bar, and okay, Ose is not able to solve, and that will give you we represented Ose by S, so S bar, and okay, Anani is not able to solve, and Anani not solving is A, so not able to solve will be the complement. Is my point well made? Hello, are you following my professors?
Yes.
Okay, great. So at this point, like I said, that's that step. Okay, you can skip, and I'm going to skip that step here. So I have to do P of D bar. Okay, and we go back and get D bar. But fortunately, we can get it from here. We can do that. So this is P of D, 1/6. So D bar will give us 5/6. Is that okay? Then times P of S. P of S is 1/8, but we want P of S bar. And S bar will be what? 7/8. That is 1 minus 1 on 8. So 7/8. By then, you had extracted the data. So you will pick it from the data, not from the question. Is that clear? But because I don't want to go back, that's the more reason why I'm picking it from here. Because it was from here that, okay, I got the data. Okay, so then times Anani not being able to solve will be the complement of what? Okay, the 1/3 probability. So that would be, okay, 2 on 3. We have that already. So 2 on 3. So at this point, okay, you just what? Multiply, okay, and simplify. So use your calculator straight away. Okay, and if you use your calculator, you will get 35 on 72. Am I right?
Yes.
Okay, very good. Because here I could do some possible reductions. So I dealt with smaller values, so I could do it mentally. All right. So please, are we all on board? Okay, who wants me to go over? Okay, so we thank God. All right, so now this will be it for II. So now let's go and look at III. Okay, I, what are we looking for? So therefore, P, okay, one of them solve the problem. So P1, okay, solved the problem. Okay, so this is where you are going to do a little more work because you are going to have more than one possibility. Okay, remember we have 3 people attempting, okay, or trying to solve a problem. Okay, so please make sure, okay, your audio is on mute. All right. Okay. So, like I was saying, take notes. You have 3 people trying to solve a problem or solving a problem. Okay. And here is the case you are being asked, okay, to find the probability that only one, meaning exactly one of them, is able to solve the problem. Okay. When you have this situation, please take notes. You are going to have more than one possibility. Because if you are saying that if only one solved the problem, then it could be that, okay, one possibility is that only Papa was able to solve the problem. Ose was not able, then Anani was not able. That is one possibility. Okay, another possibility would be that the person who was able to solve the problem, okay, is Ose. So if in that case, it means Papa was not able to solve and Anani was not able to solve. And in another situation, which will be the last possibility, in that case, only Anani was able to solve. So it means Ose not able to solve, then Papa also not able to solve. So we are going to have 3 possibilities. And you know, I told you that in probability, anytime you have more than one possibility, okay, and you are joining, okay, these possibilities, what do? You join them with all or plus. You remember what we've been doing so far. Anytime you have more than one possibility, okay, that is what we do. So basically, this is going to be the possibilities that will help us find the probability. Immediately you take one off, you are doomed, just as I told you yesterday. Okay, so in this case, what do we have? We are going to have P. Okay, so this time around, I'm assuming Papa is able to solve the problem. So it means I'm going to get A intersection B, sorry, intersection S, forgive me. Intersection what? The next one is, D. Let me use D rather. Okay, so D, then intersection A. Okay, with this one, we said only Papa is able to solve the problem. So it means S will have complement and A will have complement. Should I come again? Or my point is well made?
Please come again.
Okay, so remember what I said before coming to this. Okay, one possibility is that we said one solves the problem. Okay, so it means, okay, the three, at any point in time, the three solving a problem is only one person who is able to solve. So all along, the three are solving a problem. So you always get maybe your letters, okay, D intersection S intersection A. With this one like this, would have been that like that. But because we are looking at none of them solving, all of them will have the complement. Is that clear? So the same thing here. Here you have only one of them solving. So the one that you are saying your first possibility is able to solve, that one shouldn't have a complement on it. So here we are assuming one possibility, okay, which is what Papa able to solve, but the two are not able to solve. In that case, the two should have what the complement. Papa shouldn't have the complement. Is it clear now? Hello, is it clear now? So meaning Papa is able to solve, okay, what do you call it? Osei is not able to solve, then Anani is not able to solve, which is obviously one possibility. Then we go to the other possibility. Okay, that one will also give you P. Again, do your letters. So D intersection S intersection A. Okay, then you come and ask yourself, which possibility are you looking at? You are looking at the possibility that, okay, Osei is able to solve. So if Osei is able to solve, then it means Osei, okay, shouldn't have a complement. The others should have, because they are not able to solve. Is that clear? Is my point well made?
Yes, please.
Okay, or, okay, the last one, which will be P. Again, you do your D intersection S, then intersection A. This time round, who is able to solve?
Anna.
Anani. So the complement should be where?
On A.
No.
Sorry, on D and on S.
Okay, D and S. Okay, so now you've catered for all your possibilities. So your work becomes trivial. You are, all the intersection will change to multiplication, all the or, okay, will change to what, addition. So it means I need to find P of D. And P of D, okay, you are mature, so you will not separate it into the individual probabilities. You use them directly. P of D, what did you get for P of D? That is 1/6. Is that not it? Then times, okay, P of S bar we know that gave us what? 7 on 8. You have the data, so you just go and extract the data, then write it there. So then times, okay, P of A bar gave us what? Also 2 on 3. Then or is addition. Then you come to this one will be P of D bar, and P of D bar will be what? 5 on 6. Am I right?
Yes, please.
Okay, then times P of S. Remember, you are moving. P of S. S is what? 1 on 8. You have that data, so you just go and pick, okay, and substitute. Okay, then P of A bar. A bar is what? 2 on 3. I hope you are following.
Yes.
Then plus the last one will be P of D bar. D bar, okay, will be what? Again, D bar is here, which is 5 on 6. Okay, then times, okay, S bar, we've done it here, and that is what? 7 on 8. Okay, then times A, and A is what? 1 on 3. P of A is 1 on 3. So the rest will be calculator work, only that you have to be careful. Don't use your calculator for everything. Now you have more than a term, so use your calculator to treat it term-wise. So use your calculator to find the value here for me. Come again.
7/72.
7/72.
Yes, please.
Okay. Then the second term.
35/72.
35/72. Okay, plus the third term.
35/1/4.
35 over.
144.
Mr. Hackman.
Yes, please.
Please, the second one is 5.
The second one is what? 5 on 72.
Yes,
Not 35.
we have 5 times 2, but the numerator is 10. And then over 144, so when you divide it, 625.
No, I don't get you. What is the value here? You see, you are disputing the value here. Please, what did you get for this? This one, just feed it with your calculator. We shouldn't waste time on this.
It's 5.
5
It's,
to 7.
it's what? It's 5.
Yes,
5, yes,
please.
sir. 5.
Okay, all right, 5. Okay, all right. So now, okay, I will change it. Don't worry. Okay, so let me go and erase that. So this one should go. Okay, all right. So we are good. So are we good to go now? So everything is perfect now. Okay, so this will be equal to, okay, and then we are going to get, okay, so that will give us, so is it 59 on 144? Am I right? I hope I'm right. At this point, you use your calculator to do everything at a go. Is this point that you can't use your calculator, deal with it term-wise. Here, you can do everything with your calculator. So 59 over 144. I hope I'm right.
Yes, sir.
Okay, so now we are left with, okay, the IV and the V. Okay, so let's go and look at the IV together. So IV, okay, what do we have? Okay, we are looking at P, exactly 2. So I can write 2, okay, solve the problem. Okay, so I didn't extract it exactly as you have it over there, but I can see that what you have there is a precise, okay, or a concise form of what you have here. Okay, however, if you cannot do that, write exactly what you have here, okay, in brackets. So P, exactly 2 of them solve the problem. Put it in brackets if you don't want to stress yourself. Okay, so now this is what we have. This will be equal to, okay, so 2 of them solve the problem. Again, you are going to have more than one possibility. So it's like I have this, let me use, okay, the letters. Okay, once again, maybe just to drum home my point a little, okay, better. So I have, we said D, we have what? S, then we have what? A. So if only 2 of them or exactly 2 of them solve the problem, then it means, okay, at every point in time, you know, you deal with a 3. So if I have all the 3 and I'm saying that only 2 solve the problem, then it means it could be that my first 2 solve, but this couldn't solve. So this will have a complement. That is one possibility. So with this, you can see that Papa was able to solve, Ose was able to solve, but Anani not able to solve. In this scenario, okay, or possibility, don't we have 2 of them, okay, solving the problem? You can see this denotes what 2 of them, or represents, okay, one possibility for 2 of them, okay, solving the problem. It can also be this, D, S, what, A. This time round, okay, Papa is able to solve the problem. Okay, then the only person who is not able to solve the problem, let me put it this way, is Osei. So Papa is able to solve, Anani is able to solve, but Osei is not able to solve. I can see that in this, I also have 2 of them solving. Can you see that? So this is also another possibility, which is different from this. Then again, DSA. Okay, this time around, you can see that I will say that Papa is not able to solve, but Osei and Anani are able to solve. So in this case, again, I have, okay, 2 of them able to solve, okay, which represent a different possibility here. So this will be the 3 different possibilities that you can look at. So with this one too, we'll join them with what? Or. So we are going to get what? Please, I hope you are following. Is my point well made? Hello, is my point well made?
Yes, please.
Okay, so my first possibility will be D able to solve and okay, S able to solve, and okay, A not able to solve. One possibility. Or my second possibility will be P, okay, D able to solve, and what? S not able to solve, and A, okay, solved. Or, okay, the last possibility, P, okay, D not able to solve, and okay, S solved and A solved. Is that clear? Exactly. As you mature, some of these things you don't have to do it. You put it here directly, but I use that to explain or drum home my point better. So this will give us, at this point, it should have been P of D times P of S times P of A bar plus P of D times P of S bar times P of, but all that can be done mentally. So you know you need to go and find P of D. P of D, you are told, is what? 1/6. Hello, are you following? Okay, then times end is what? Intersection is for end, which is multiplication. P of S. P of S will give us what? We are told that is 1/8. Times P of A bar. A bar will give us 2/3. You have all the data there. So plus, then P of D. And you can see that here, it is not necessary, just like, let me go back a little. I know some of you, when presenting your solution, you will put this in brackets. It's not necessary. You deal with the multiplications first, or before you come towards the addition. So it's not necessary to put each of them in brackets. Okay. However, if you can do that, okay, if you have time, which obviously you will not. Okay. So now what do we have? P of D, again, 1/6. Okay, times P of S bar. S bar will give us what? 7/8. Okay, then times P of A, and P of A is what? 1/3. Okay, then plus P of D bar. D bar give us what? 5/6. Okay, times, okay, P of S, and that is 1/8. Then times P of A, 1/3. I hope I've done the right substitutions. Okay, so at this point, I'm going to rely on you for each term, the value. So this term, what will you get?
1/72.
1/72. Your second term plus,
144.
come again,
7 on 144.
7/144. And your last term, the third term,
5 on 144.
5/144. Okay, so everything put together will give us, is it 7/72? Hope I'm right. Because this contains this. This will go. Will it give us 7/72?
Yes, sir.
Okay, all right. So this gives, okay, our final answer for IV. Okay, so we are going to do that of the V, our usual statement. So therefore, what are we looking for? P at least, okay, 1. Okay, solved the problem. Okay, and in this case, remember I said, anytime you see at least 1, what should you use? At least 1. What relation are you supposed
1 minus P none.
Okay, so it will be 1 minus P none. So here the none is referring to, like, a none solve the problem. Is that not it? So it will be P none, okay, solved the problem. Okay, which will be equal to 1 minus, remember we've done none solve the problem, and that is the II. And II gave us what? 35 on, okay, 72. Okay, go and check whether I'm right. I think so. Okay, so now this will be equal to, okay, so that gives us what? 37, okay, over 72. Okay, so this will be it for the solution to, okay, this assignment. Is my point well made? Remember, if this happens to be your rough work, don't forget to strike it out. Okay, however, you will need it as you mature, so take notes. Point well made. All right, okay, so please, any questions at this point? Are we all fine? Okay, so we thank God, okay, for your contribution as well, and we thank God that you are fine. Okay, so on that note, thank you very much, okay, for a successful lesson.